Good morning, everyone. Hi, how are you? I hope that you're all doing well and are staying safe and are healthy and are happy. I miss you lots, but today what we're going to do, the next investigation, which is looking at Newton's third law of motion. So what is Newton's third law of motion? Well, this is when an object exerts a force on a second object, and the second object exerts a force on that first object with equal strength, but in the opposite direction. So what does that mean? So that's what we're going to look at today. Okay, so here we go. All right, so Newton's third law. All right. So when you are leaning on a wall, so maybe you're talking to someone or you're just taking a break or reading a book or whatever, you're leaning on a wall, you apply a force to that wall. We figured that out in our last investigation. But the wall is also applying a force on you that is equal to the force you apply to the wall. So the force of the boy is going towards the wall and the force of the wall on the boy. Okay, so you can get up and lean on a wall and see what you may be feeling. Okay, so what directions are these forces working in? Well, when we look at this, the force of the boy on the wall is in the exact opposite direction to the force of the wall on the boy. So when we look here, the boy leaning on the wall is leaning this direction. And then when we look at these, if we were to be able to like cut this in half or fold this in half, it would be the same exact as this force on the wall on the boy. So in every case that there is a force applied, there is an equal and opposite force applied back on the first object. Okay, so Sir Isaac Newton, he's our guy who created the laws of motion, figured this all out and stated it in a law. So when an object exerts a force on a second object, the second object exerts a force on the first object with equal strength, but in the opposite direction. Okay, so the boy is the first object exerting a force, and that's on the wall. And the wall is the second object exerting a force on the boy. So it's the one object exerting a force on the second. Okay, so since the force happens to two objects, you can think of it as two forces, and we call those action-reaction force pairs. Okay, so for example, the force of the boy on the wall is the action force, and the force of the wall on the boy is the reaction force. Sorry, I got a little tripped up there when I was saying that. Okay, so the boy leaning on the wall is the action force. The force of the wall on the boy pushing back against the boy is the reaction force. Okay, so let's look at an example that involves movement. So look at the system of the girl's hand in the ball. The hand's force on the ball is the action force. Okay, so this girl here, she is smacking the ball down. Okay, so that's the action force. So what is the reaction force? Well, the reaction force is the ball's force on the hand. So the ball's force back towards the hand. So let's draw and label the reaction force. Both arrows should be the same length. Why do we think that is? Well, when we think about what Newton's third law of motion is, the second object, which is the ball, has to have an equal strength of force in the opposite direction. So we're going to draw it in the opposite direction, but of equal amount. So the length of the force arrow indicates the strength of the force, and the forces are equal in strength. All right, so if the strength of the forces are the same, why does the ball move but the hand does not fly backwards? So that's probably something you're like, well, why is her hand not going back in the air? Okay, so the hand is part of the girl, and the girl has a much greater mass than the ball. So since the girl has a lot more mass, a lot more matter, her hand does not fly in the backward direction. So that is a big reason why even though the forces are the same, she has more mass and more matter. Okay. So let's look at an example that involves pulling instead of pushing. So look at the system of the plane and the banner, and we're going to draw arrows to represent the action and the reaction force. Okay, so the plane is pulling on the banner. All right, so the plane exerts a force of 200 newtons on the banner. How much force does the banner exert on the plane? Well, when we think about this, if we think about back to Newton's law, third law of motion, if the plane is the first object exerting a force, the banner's force on the plane should be equal, but just in the opposite direction. And we see this here. They have done that, right? And so it should be 200 newtons in the opposite direction because it has to be equal. Okay. So observing examples of Newton's third law of motion. So we're going to look at 3 videos and it gives us a couple of more examples. All right. So how is this hydroflying video an example of Newton's third law? All right, so let's watch this video here. So it looks like he's on a jetpack of some kind that is pushing him up into the air. That looks like a lot of fun. I feel like I would probably fall off almost immediately. Okay, so let's look at the question that our notebook had about this. So how is the hydroflying video an example of Newton's third law? And so we need to use the terms action force, reaction force, and opposite direction. Okay, so watching this video, again, all right, so the jet here is our action force because he wouldn't have been able to get out of the water if there was no force being placed by that jetpack there. So the jets are our action force on the water, propelling the water out. So we can see that the action force on the water from the jet, because the water is propelling that water out there. Okay, so the water then is exerting a reaction force in the opposite direction on the jetpack, okay, pushing the jetpack and the man upward. Okay, so that would be our response to that. So the water exerts its reaction down here, pushing the jetpack and the man upward. Okay, so that would be, so the jet exerts an action force on the water, propelling the water out, and then the water exerts a reaction force in the opposite direction on the jetpack, pushing the jetpack and the man upward. Okay, let's do another example. All right, so how is this billiards video an example of Newton's third law? And again, using the terms action force, reaction force, and opposite direction. So watch this here. Okay, so that's the cue ball, that's the white ball. Okay, that hit the red, I believe 7 there. Okay, so let's rewatch that. So long, we don't need it to be that long. Yeah, the red 7 there. Okay, so again, so what do you think there? Well, so the cue ball, which is again the white ball, is exerting our action force, okay? So this here is the action force exerted by the cue ball on the 7 ball, pushing it forward. So that pushes the ball forward, okay? There is a reaction force of the 7 ball on the cue ball that points in the opposite direction, right? Backwards. Okay, so we see it's that, and then it did kind of come back there a little bit, and then it started going back the other direction. Okay, so again, the cue ball exerts an action force on the 7 ball, pushing it forward. All right, so there is a reaction force of the 7 ball on the cue ball that points in the opposite direction, backward. All right. So let's do another example here. Okay. How is this bubbles video an example of Newton's third law? And prepare a statement in your notebook. We're just going to do this together. All right. So again, we want to use the terms identify our action force, our reaction force, and opposite direction. Okay. So we'll play this one. Oh, so he's blowing bubbles here. Oh, I thought it was going to be a real big one there for a second. Okay, so this one here, what do you think our action force is? Well, if you said that the air of him blowing the bubbles is the action force, you would be correct. So it pushes on the soap in the wand. All right. Now, this part is kind of more difficult, but what do you think the reaction force is? Well, so the soap, of course, pushes back on the air. So the soap in the bubble pushes back on the air in the opposite direction, even though we can't see it. Okay, so the push of the soap is the reaction force. So that one's a little bit harder to think about sometimes, okay? All right, so what you'll be doing today, so I'll go ahead and exit out of this and stop sharing my screen. Okay, so what you guys are going to do today is you are going to identify action and reaction forces from examples that I give you in the assignment today, okay? So if you have questions, of course, please contact me, whether it's on Text Remind or it's here on MS Teams. I have noticed that I haven't, for whatever reason, been getting all of my messages and notifications for when you guys are messaging me on Teams. So it's probably best on Text Remind. So if you haven't signed up, you still can do that, whether it's your parent or you. So go ahead and do that. It's all available for you. And so I'm not quite sure what's going on with MS Teams with my notifications, okay? All right, guys. Well, I hope you have an awesome day. And I miss you. I love you. And stay safe, stay happy, and stay healthy. Bye, guys.